O mundo que conhecemos é um mundo digital, acessível, disponível e dominável pelo poder do toque. Cada vez que apertamos um botão, cada vez que estabelecemos uma conexão, cada vez que efetuamos uma transação, um universo de números e equações se combinam para transformar todas as facilidades que temos ao alcance de nossas mãos. Acostumados, adaptados e mimados pela tecnologia, sequer imaginamos que as coisas nem sempre foram assim. Se por um lado, há léguas de distância entre o ábaco e o computador, há também padrões que os aproximam. A história nos ajuda a nos situar no tempo e no espaço e nos permite vislumbrar como a busca por soluções práticas alavancou o desenvolvimento daquilo que chamamos de matemática. Esse é um breve esboço de como o desvendar deste mistério começou. Desde que o mundo é mundo, o ser humano sempre precisou solucionar problemas e superar desafios para que a vida pudesse fluir e a civilização progredir. A cada etapa do progresso humano, novas soluções eram encontradas para sanar as necessidades de um determinado contexto. A história é justamente esse relato de avanços e retrocessos registrados para que hoje pudéssemos entender o motivo e o modo como os povos que vieram antes de nós lidaram com seus desafios. Na antiguidade, toda vez que um rio transbordava, era difícil saber que pedaço de terra era de quem. Então, como demarcar terras periodicamente inundadas? Como mensurar a passagem do tempo? Como medir a quantidade de alimento em uma negociação? Problemas que para nós hoje não parecem coisa de outro mundo, mas que em outros tempos foram a base para que a matemática se desenvolvesse e nossos problemas pudessem ser outros.
Bem, talvez a gente deva separar a história da matemática em si, da ciência matemática, ou ciências matemáticas, como alguns preferem, da história da matemática. Porque a matemática nós imaginamos que venha como algo inerente até ao ser humano na forma de classificação, porque contagem de números é uma maneira de você classificar. Você falar 2, 3, você está falando imediatamente de um agrupamento, de uma coleção que tem aquela característica. 2 elementos, 3 elementos. E isto é, intuitivamente, uma maneira de classificar. E a classificação é algo muito, como disse, inerente, uma característica do ser humano. Alguns animais também classificam, mas os homens classificam mais. E, portanto, a matemática vai se perder na origem do próprio homem. Agora, a história da matemática, esta tem uma história em si que começa com os primeiros relatos.
Virtually every culture in the history of the world has had some kind of mathematics. And I used to tell this to people and they would say, "Oh, you're telling me different cultures have different kinds of mathematics. 2 and 2 is 4 everywhere." Well, that's true. 2 and 2 is 4 everywhere. But how you write the numbers, what you do with them, what role mathematics plays in your society, that is very different from culture to culture. The society, and this is so my first principle is virtually every culture has some kind of mathematics. Second principle is that a society develops kind of mathematics that solves problems that that particular society wants to solve.
Mas onde, como e com quem começa a matemática?
When you think about ancient mathematics, whether you're talking about the Mayans or in India or in Mesopotamia or in Egypt, the really sophisticated mathematics was to try to understand the heavens. And this belief that if you understood where the planets would be at a given time, if you understand the conjunction of different planets with the position of the sun in the heavens, that you might be able to predict when the king would die, or you might be able to predict when a famine would come. And so this was seen as very powerful information. And so it was closely guarded.
Knowing how the stars moved and how the heavens moved was critical. Astronomy is the basis of a lot of ancient mathematics. That was the motivation for studying trigonometry and for being able to figure out, even the world isn't flat. People usually knew that the world was a sphere, but still, you had to be able to figure out where things were going to be and when things were going to happen. And if you could predict eclipses, which were a very significant thing to happen. If the sun suddenly went dark, that was a major problem for people, And if you could predict that, then yes, you had power. And that was very important. I remember reading in China, when the emperor hired people to do this, if they got it wrong, they lost their jobs for sure. They had to be able to do it correctly. So knowing the mathematics, especially behind astronomy, was very critical in a lot of these civilizations.
No mundo antigo, não havia dúvida a respeito da existência de Deus ou dos deuses. Este mundo não era apenas protegido pela presença da divindade, mas também precavido do vazio do abandono. Tudo acontecia por um motivo, e os mistérios, talhados pelos deuses, inquietavam os homens que buscavam por respostas. Olhar para o céu era talvez um jeito de descobrir os recados do transcendente e, quem sabe, encontrar um jeito de se comunicar com seus deuses. Ao contemplarem os céus, eles descobriram padrões, ciclos e regularidades que regiam a natureza. E a partir dessas descobertas, podiam fazer previsões com base na matemática infalível das sequências naturais. Mas como os antigos enxergavam o poder dessa incrível precisão matemática?
There's some indications, even as far back as as in ancient Babylonia, that one of the motivations for mathematics was for the rulers to get things right. You wanted to be able to do things fairly. That was your job as the king, to make sure that everything worked correctly, and so you needed mathematics to do that. Even more explicitly, there's a very nice book that was written in Hebrew in Spain in the 12th century, sometimes early 12th century, by Abraham Barchia, and it was a book on geometry, and he was very emphatic that people had to study geometry because you needed to do things correctly. When somebody died and you had to divide up his land among the children, and the oldest son is probably supposed to get twice as much as the other children or whatever, you had to be able to do it right. And he said people don't know how to do this all the time. If land is not necessarily a square where it might be easy to divide it up, but if it's different shapes, and that's what he was interested in. He said, God requires that you do this correctly, and you have to learn mathematics to be able to do it correctly.
A exatidão observada na natureza possivelmente inspirou no homem a necessidade de precisão para governar seus projetos, administrar reinos, construir templos, computar bens, estimar o tempo, prever fenômenos naturais e planejar o plantio, a colheita e o armazenamento do alimento. Essas atividades eram essenciais para a manutenção da vida e todas eram feitas de matemática.
And the other thing you find in every advanced civilization is the study of the heavens. The heavens are fascinating because we've got three basic periods. We've got the day, we've got the lunar month, and we've got the solar year. And they're not compatible. Early civilizations hoped that it would be a whole number of days that fit into a lunar month and a whole number of lunar months that fit into a solar year, but it doesn't work as nicely as that. And so they began to have to work on these cycles and cycles within cycles. And then once they start tracking the planets, things get incredibly complicated. And if you want to understand when there's going to be a lunar eclipse or when there's going to be a solar eclipse, now you get into really complicated use of numbers. And again, you find this in every advanced civilization, whether you're in the Americas or in Africa or in Europe or in Asia. They were all struggling with how to use numbers to understand these patterns. And the simple fact that the position of the sun as it travels through the heavens on its yearly cycle, the position of the sun is extremely important in predicting when rain will fall, when the seasons occur. There was this belief that the positions of the other heavenly bodies also had to be important, had to have some kind of predictive power. And so looking at the numerical patterns that people worked out for these astronomical bodies and trying to figure out how to use them to predict, first of all, where the bodies would be and then what that influence might be. We find this in all of these civilizations, and it drove a lot of very advanced thinking in the properties of numbers and how you work with numbers and properties of mathematics, these patterns that people were seeing in the heavens.
Os povos da antiguidade acreditavam que seu destino era traçado pelos deuses e que o comportamento dos astros influenciava diretamente a vida dos homens. Perder a proteção dos astros era estar condenado a uma vida de infortúnio. Portanto, saber o que fazer para manter essa proteção era essencial. Muitas das construções antigas mais imponentes são justamente templos e zigurates, erguidos para homenagear e apaziguar os deuses. Contudo, a história aponta para outra geografia como berço da matemática que conhecemos, a civilização grega. Todos os passos pouco registrados das demais civilizações são tidos como uma prática funcional da matemática, coisas necessárias para tocar o comércio, as contas e as construções. Mas os gregos lançaram outro olhar mais profundo sobre a matemática, e as coisas começaram a mudar. Mas certamente, eles se inspiraram em outros modelos.
The ancient Greek mathematicians all say they learned geometry from Egypt. I figure they ought to know. Okay, so you go and look at, well, we've got a lot of stuff from Egypt, but there's a lot we don't know about Egyptian mathematics. But we know they built the pyramids, and we know that they could find the volume of pyramids and the volume of pyramids with the top cut off. And we certainly know that they could solve problems. When the Nile flooded in Egypt, it got rid of all the boundary markers, and then when the Nile floods receded, they had to go lay out the fields again. Okay, so you learn geometry to do that. You learn geometry to build pyramids. You learn computation methods to build pyramids too, because an incredible job all the workers that you have to organize and all the stones that you have to figure out where they are and where they should go. It's a tremendous accounting problem. So Egyptians could do all kinds of cool stuff.
If you read the introduction to the Rhind Papyrus, which is this one of the major documents we have of ancient Egyptian mathematics, it says sort of to figure out all secrets or something. They were dealing with how to divide up beer and bread, which was, for instance, one of the ways they paid their workers or something, and figure out various things about that. There are some geometrical ideas about measuring. You can see some interesting things about pyramids. And they did calculations. The Egyptians, one of the things that's interesting about Egyptian mathematics is they had this way of expressing fractions all as sums of what we would call unit fractions. So they would never write something like 2/5 or something. They would always think of it as a sum of unit fractions. So 2/5 is like 1/3 plus 1/15. That. So they certainly had power, and they were the ones who understood how to do the calculation. So that's why I say mathematics was certainly a source of power.
Não é de hoje que saber é poder. Na antiguidade, o conhecimento especializado era a posse dos sacerdotes. O conhecimento matemático pertencia a eles, mas era compartilhado com seus escribas, os responsáveis por manter registros precisos do que acontecia, quer com palavras ou números. Além das grandes construções, são os registros desses escribas que nos permitem ter uma noção do tipo de matemática que era usado na antiguidade. O registro matemático mais antigo é o papiro de Rhind, onde o escriba Amoses detalha 85 problemas matemáticos. Mas os mais notórios talvez sejam os tabletes de argila babilônios, encontrados no Museu de Yale, que nos apresentam a matemática dos mesopotâmios.
It's believed, although we're not sure, that the impetus for the mathematics developing in the first place was record keeping, to keep track of trade, to keep track of what people had, to deal with taxes. One of the things they certainly did was what you might call surveying. Whenever you had a land, you had to figure out who owned what and how to divide it up and all that. And they developed various techniques that we often call solving quadratic equations. Their calculations were much more sophisticated than the Egyptians. They developed this place value system of base 60, and they could calculate all sorts of things, from square roots to various kinds of measurements, and sometimes they did them to all sorts of a very many places, what we would call decimal places.
Os babilônios já sabiam o teorema de Pitágoras muito antes desse nome surgir na história. Seu modo de contagem numérica de base 60 ainda hoje é usado para dividir minutos e segundos, pois o número 60 possui mais divisores do que qualquer outro número inteiro. Mas ao passo que os egípcios e babilônios descobriam novas maneiras de medir tempo e espaço, do outro lado do mundo, os maias desenvolviam uma matemática similar para construir suas pirâmides e marcar seus ciclos. Mas como povos que a princípio não se comunicavam, conseguiam concluir e realizar coisas muito parecidas. Será a matemática algo cultural ou universal? Haveria aqui a revelação de uma verdade mais profunda? Inclusive sobre a possibilidade de haver um criador matemático por trás de tudo?
don't know enough about the Mayans. You know, the Spanish, when they came in and conquered Mexico and Central America, they destroyed an awful lot of the Mayan documents. So we know they had a fairly sophisticated arithmetical system. They used base 20 in general, and they could calculate dates and you know, from how long a reign was and when a certain king was born or when he died and things like that. And they had this very extended calendrical system. We don't know too much about other parts of their mathematics other than what you can infer from the fact that they also did a lot of building, and clearly to do building, you needed to know mathematics. You know, some of their buildings are set up, you know, with astronomical orientations, so they certainly understood motions in the sky. In particular, we know that they followed Venus, and its appearance in the sky determined a lot of their pieces of their calendar.
Mas algo aconteceu na Grécia. Tão logo o pensamento matemático deixou de enfocar o uso e passou a observar o motivo. Ao invés de se perguntarem para que ou como a matemática poderia ser utilizada, perceberam que seu real propósito era responder o porquê das coisas.
These kinds of observations can be found in all of the advanced civilizations, but something very special happened in Greece starting about the 4th century into the 3rd century before the Common Era. And that was the marriage of mathematics with philosophy. And the thing about the Greek philosophers is that they firmly believe that you can't make any assertion without backing it up, without having a justification for it. And so that came into mathematics. Before that, when you look at the Babylonians, you look at the Indians, you look at the Egyptians, they had devised all of these rules that worked. And they were also rules that tend to be kept by a small clique of people, usually a priestly class of some sort. This was esoteric knowledge because this was knowledge that would help you understand the heavens. But the Greeks were much more open about their mathematical knowledge. And they also wanted to be able to justify it absolutely. When I make a particular mathematical claim, it's not just because my teacher has told me this is so. I want to be able to justify it.
What was unique about the Greeks is that they had proof by contradiction in geometry. Nobody else seems to have done that. And the way you prove something by contradiction is you assume the opposite of what you're trying to prove. And then you show that that leads to a contradiction. And therefore, the thing you're trying to prove must be true. But the idea that you would try to prove something in geometry, which is, after all, supposed to be about truths, by assuming that it's false, that seems like a really, really weird thing to do. But the Greeks, because geometry and philosophy grew up hand in hand, and because philosophical arguments used the principle of contradiction, it was a natural thing for them to do.
And the real person who led this effort was Euclid. So we're now looking around the year 300 before the Common Era. Euclid almost certainly was not acting alone. He almost certainly was the head of a school in Alexandria. And he set what would be the standard for mathematics in the thousands of years since then, which was that you need to carefully justify any mathematical claim that you make. And you do it by having very precise definitions, say exactly what your terminology means. And this goes right back to Greek philosophy, precise definitions of what do you mean by different terms. And then what are your assumptions? Clearly state the assumptions that you're making. And then given those clear definitions and those clear assumptions, you can begin to build up your mathematical edifice. Euclid also happened to work in Alexandria, the Museum, the Temple of the Muses that had just been established there. And that would continue for 600-700 years to be the most exciting center of mathematics in the entire world. That's really an incredible legacy, 600 to 700 years. This one location was the center for all that was going on in mathematics. And I think one of the other things that contributed to the power of Greek mathematics was to have a center. And one of the things that he did was to greatly refine trigonometry, this study of angles and how they relate to arc lengths and chord lengths. That's something that had come up in earlier astronomical work of Greeks. And again, when I say Greeks, I really mean the Hellenistic civilization of the whole Eastern Mediterranean, not just in Greece itself. But around the 2nd century before the Common Era, these tools of what today we refer to as trigonometry were developed in their earliest forms. Ptolemy went a great deal toward extending this. And then sometime around that same time, 2nd, 3rd, maybe as late as the 4th century of the Common Era, these ideas from the Hellenistic Eastern Mediterranean spread to South Asia and were picked up by Indian astronomers. And about the same time that mathematics was fading in the Eastern Mediterranean, it was beginning to grow in South Asia and India.